Grade 3, Chapter 13, where we will be teaching about tenths and hundredths. Now this may seem familiar, because they are. Remember last chapter where we told you about things like fourths, fifths, sixths? Essentially, tenths is just the same thing. It's when the denominator, or the bottom number, of a fraction is 10, and hundredths is, well, when it's 100. So first we're going to start with tenths. You can use a fraction or decimal to name parts of a whole. We went over this in the last chapter. So now we're going to connect it to real life. Yay! And in the form of money. This is the Canadian dime, and that's the American dime. 10 cents is a tenth of a dollar. Read 1/10. Fraction 1 over 10. The decimal would be 0.1, or in the case of money, it would have the dollar sign and then 0.1, and then you have to add a 0, because money has to have 2 decimal places. This one. I'm sure we've all seen this one. Well, maybe not this one though. But that's the nickel. So a nickel is 5 cents. That would be 5/100th of a dollar. Read 5/100th. And the fraction would be written as, well, 5 over 100. And the decimal would be 0.05. Because when it's to 1 decimal place, it's a tenth. When it's to 2 decimal places, it's 100. 3 decimal places, thousandths, 10,000ths, 100,000ths, millionths, and so on, so on, so on. For money, it would be a dollar sign and then 0.05. Now let's do some practice. Write a fraction and a decimal for the part that is shaded. We can tell that this is 10 parts in total. So the denominator of the fraction would be 10. And there's 4 parts that's shaded. So what do we know about fractions? They're parts of a whole, and the part is on top, or the numerator. The numerator would be 4. That's 4 over 10. We can simplify that into 2 over 5. But since we're doing tenths, we're not going to do that. The decimal would be, what did I tell you about tenths? They're always to 1 decimal place. So what's on top? 4. This is to 1 decimal place. There is 1 number after the decimal dot. And this one. This one is still 10 parts in total. This time there's 5 parts shaded. So the numerator would be 5. And of course, it's a tenth. Meaning that there would be only 1 digit after the decimal place. The digit would be 5, since 5 is a numerator. Now what about this one? Oh, they're just getting 1 by 1 larger, huh? It's still 10. And this time there's 6 shaded. We put 6. Now it's 0. What? It's tenths, meaning that there's only 1 digit. And that digit, well, is right up here as a numerator. So that'd be 0.6, or 6/10. Of course, you can't say tenth as in just with a th, it's spelled with an s. Some people see this and they think tenths. That's really not how you say it. Now, write each fraction as a decimal. This is 7/10. It has a 10 as the denominator. So we know that there would be only 1 digit after the decimal place, and that digit is a numerator. Ta-da! The decimal would be 7/10, just like how this fraction is read 7/10. Or you could read it as 0.7. Well, that's 3/10. Well, it's the same thing. because it's still a tenth. There's only one decimal place. And 9/10. It's still the same line of logic. What about this one? Write each decimal as a fraction. Okay, you might have heard of 1.5, 2.5, and we all know that 0.5 is a half. But in this case, we can't write 1/2 because it's asking us to write it as a fraction, and for this activity, we're learning about tenths. So naturally, we are supposed to write it with 10 as a denominator. You could simplify it after, though. So 10 is the denominator since there's only one decimal place. And this one decimal place is a 5. So 5 is the numerator. This simplifies into a half on a side note. Now what about this one? Well, it still has only one decimal place. So the denominator is still 10. And that decimal place is a 4. So the numerator would be 4. And this one, 0.1, 1/10. Well, what would a fraction that reads 1/10 look like? 1/10, 1/10. Those are the different types of, well, thinking that you could use to reach these conclusions. Now, in section 2, we're going to add in hundredth. This model shows 5/10 shaded. But first, we're going to go over tenth. You can write 5/10 as a decimal. 0.5 with only one decimal place. And you read it as, well, 5/10. This model shows 12/100 shaded. So the fraction would be 12/100 or 12/100. And I told you before that tenth has one decimal place, and hundredth has 2, thousandth has 3, and so on, so on, so on. So this time we have 0. something something. The numerator is 2 digits, so we put those 2 digits there. The decimal would be 0.12 or 0.12. Not many people say that though. 12/100 is the proper way to read it. Let's write it out. 12/100. Done. So now let's do some problems. Write each as a decimal. We know that this one has 10 parts, so that's a tenth. There would only be one decimal place after. And there's 7 sections that are shaded. The numerator would be 7, and there's one decimal place. 7 is 1 digit. We'll just plop the 7 here. 7/10, 0.7. This one also has, well, 10 parts. It's still a tenth. Except this time, there's 6 as a numerator. 6 is still a single digit. Then, because of that, we plop a 6 there. 6/10, 0.6. But this one, and this one, these two, have 100 parts. Then it makes that 100th, where there would be 2 digits after the 0. Now, the numerator for this is 31. 31 is 2 digits. We just plop 31 here. 0.31, 31/100. And that would be how you would read the fraction 2. What about this one? This one it's a little hard to see, but it's 79. And there's 100 parts. So it'd still be 100th. 79 is 2 digits, 7 and 9. Then we just flop that there. 0.79, 79/100. Now we keep going without diagrams this time. This one has 10 as a denominator, so it'd be a tenth. 0 point and only one digit. The digit is a numerator, and the numerator is a single digit. So we just put 7. 0.7, 7 tenths. 7 tenths. Now this one, 3 tenths. 3 tenths, 0.3. But this one has 100 as a denominator, so it'd be something hundredths. 59 hundredths. Now we know that this is 79 hundredths. And if we know that, then how many decimal points or digits after the decimal point would there be? 2. Then we just write 0.59. Oof. This one is just like that one. There's 2 decimal places. 0 point, and there's 2 digits up here, so 0.15. Oh, okay, these are fun. There's 2 decimal points, right? Since it's 100th. But there's only 1 digit up here. So instead of putting the digit over here, because that would mean that it'd be like this, and that's wrong, we put it like this. 0.08. 8 hundredths. Since for hundredths, we start reading from here. Now we move on to, well, question number 10. Oh, 10, a tenth. Interesting. And we know that tenths, by now, have only 1 decimal place. And there's only 1 digit as the numerator. So we put it there, 0.9. This one is, well, a hundredth, and it's classic since it only also has 2 digits for its numerator. And then it'd be 0 point, and you just flop the numerator there, 64. Question number 12 is just like question number 9, since there's only 1 digit up in the numerator, even though we're supposed to have 2 decimal places. But remember, we put 0.01, because in decimals, if you take out a number after, then that means that the number is 0. You can't take it out if it's something like 0.11 or 12 or anything except 0. Well, you just don't take it out. Unless there's something after the 0. If there's something after the 0, you can't take the 0 out either. But that's significant digits, which we learn much later on in life. Question number 13. Oh, 13. 14 over 100. So 14 hundredths. Hundredths always has 2 decimal places. And 14 is 2 digits. And we just plop it there. Now we're done. That was simple. Or, well, quick. So we take a break from all of that, and we go over some problem-solving strategies. Bob, James, and Ruth are playing a decimal game. One person has 0.02 points. One person has 0.25 points. One person has 0.6 points. Bob does not have the least number of points. Ruth's score is in the hundredth. James has a score equivalent to 6 tenths. What are the scores of each player? Okay, so what do we know? There's 0.6 as a score, 0.02 as a score, and 0.25. Now James has a score equal to 6 tenths. J equals to 6 tenths. Bob does not have the least number. So Bob, the least number of points is 0.02. Since 0.6 also equals to, remember, If you wanted to have 2 decimal places, then you just add a 0. Since if it isn't a 0, then we can't take it off, and it'd be 2 decimal places anyways. But this 0.6 is equal to 0.60 is equal to 0.600, and so on, so on, so on, so on. You could add an infinite number of zeros as long as you don't add anything except zeros. Don't add anything except zeros, I'm serious. Bob has, well, he doesn't have the least number of points, so he doesn't have, if you put a slash through a equation sign, well, equal sign, it means it isn't equal. So Bob isn't that, and Ruth's score has, well, 2 decimal places in the hundredth. What are the scores of each player? So now we plan. We could use logical reasoning, in which we match each of them up. We could draw a picture or a diagram. We could make a graph, but, well, we can't really in this because there's nothing to graph. We can add it out, act it out, make a table or list. We can't do that either, so these 2 are out. We can't find a pattern because there's no pattern to find. Guess and check, we would have to go like, oh, does Bob have this? No, according to the facts, he doesn't. And that would take a lot of time. I don't recommend that. Write an equation, it's not exactly algebra. Work backwards, you technically could, but not really. And solve a simpler problem, there's not really much simpler problem to solve here. Guess and check would be very slow. Drawing a picture or a diagram would also be very slow. I know that it might tell you to act it out, but the chances of you being in a test with 3 of your, well, 2 actually, of your friends to come over and act it out without getting your test taken away by the teacher is not exactly possible, so we're not gonna do that. Let's do some good old logical reasoning. Step 3, carry out our plan. Since we know that James has something equal to 6/10, and 0.6 is, well, 6/10, then we know that James has 0.6 points. And Bob doesn't have the least number of points. And the only other point left is 0.25. So Bob has 0.25. And Ruth's score is in the hundredth. And 0.02 is in the hundredth. This fits with everything that we know. So is the solution reasonable? Yes. And we reread the problem to make sure that we got all our facts straight. It says Bob, James, and Ruth are playing a decimal game. One person has 0.02 points, one person has 0.25 points, one person has 0.6 points. Bob does not have the least number of points. Ruth's score is in the hundredth. James has a score equivalent to 6/10. What are the scores of each player? Well, we know that we answered the question, and we got our facts straight. So our reasoning is sound, and our solution is, well, reasonable because our reasoning is sound. How can we check our answers? We could do it again, or we could run it through logic. Yeah, that's about it. You can't really act it out without doing it again. That's the basic gist of it. Now we do some practice. Ed, Marcia, and Jean are playing a game with decimals. Each person has one of the following decimals: 0.5, 0.54, and 0.2. Ed's number is not equivalent to 5/10 or 2/10. Marcia's number is greater than Jean's number. What are the numbers of each player? So we know that 5/10 in decimals is equal to 0.5 because the 1 decimal place, and 2/10 is equal to 0.2. Now, the only score except, well, 0.5 and 0.2 is 0.54. So Ed has 0.54 It's recommended to write this down in full sentences once you're done. Marsha's number is greater than Jean's number. Which one's bigger? 5/10 or 2/10? Well, we learned in fractions that when the denominator is equal, you compare the numerator. And we know that 5 is bigger than 2. So 5/10 is bigger than 2/10. Or 0.5 is bigger than 0.2. And Marsha's number is a greater one. So Marsha has 0.5. And Jean is the last one, and he has 0.2. We make sure that our facts are straight. There's 0.5, 0.54, and 0.2. As number is not equal to 5/10 or 2/10, Marsha's number is greater than Jean's number. Okay. What is the number of each player? Well, we answered that. We got our facts straight. And our reasoning is sound, so the answer should be what we wrote over here. Cassie has 100 marbles. 28 hundredths of them are blue. 30 hundredths of her marbles are green. The rest are red. What decimal represents the number of marbles that are red? Now this is some good old-fashioned subtraction that we learned last unit. There's 100 marbles. 28 out of 100 of them are blue. Now, 28 out of 100. There's 100 marbles in total, so 28 are blue. And 30 hundredths is 30 over 100 of her marbles are green. And since 30 over 100 is also 30 out of 100, then, well, 30 hundredths of 100 is 30. So 30 marbles are green. 30 are green. The rest are red. Now we could just decide to do 100 minus 28 equals to 72, and then 72 minus 30 equals to 42. 42 marbles are red, so what decimal represents them? Well, there's 100 marbles in total. 42 over 100 are red. That'd be 42 hundredths, and we know that 42 hundredths is 0.42 read out properly. Another way to do this is, well, you know that 30 hundredths is 0.30, and then you do multiplication of decimals, which I don't think we've learned yet. Now let's do some more connection to the real world. Decimals and money. 1 cent is 1/100th of a dollar. That's a Canadian cent, that's the American cent. Numbers, the cent sign looks like a C with a cross through it, and the dollar sign looks like an S with a cross through it. 1 cent or 0.01 of a dollar, or 1/100th of a dollar. And 5 cents, the nickel, that's Canadian, that's American. 5/100th of a dollar. So that'd be 5 cents or $0.05, 5/100th of a dollar. And yeah, that's about it. Oh yes, and by the way, we stopped creating pennies. Well, Canada stopped making pennies in, I think, 2014 or 10, one of them. We stopped creating pennies a while ago, though. They became too expensive since, well, pennies had copper in them, had too much copper in them. 10 cents would be 10/100th of a dollar. Now, one thing that I want to tell you, 10/100th is just equal to a tenth because of equivalent fractions. 10 cents or 10/100th of a dollar is equal to 1/10th of a dollar. A nickel is also equal to 1/20th of a dollar. 25 cents or 25/100th of a dollar. And 25 hundredths of a dollar is also equal to a quarter of a dollar, which is why a quarter is called a quarter. Ah, that's the Canadian quarter, that's the American quarter. Okay. It's very interesting because for the American ones, they're just showing us the heads. But for the Canadian ones, they're just showing us the tails side. Now, 50 cents, or 50 hundredths of a dollar, okay. This isn't 50-cent coins because we don't produce those anymore. And 50 hundredths is just a half. So 50 cents is a half of a dollar. It's also equal to 5/10, which is why sometimes you will not see just, well, 0.5 by itself. And 100 cents is equal to 100 hundredths of a dollar. Or just, well, a dollar. 100 cents is equal to a whole dollar. America, the United States, has $1 bills. I'm not sure about the other countries. Many countries do have $1 bills, but Canada doesn't. Write a fraction for the part of the dollar that a coin represents. Now this one is, it says 5 cents. It's a 5-cent coin in Canada, the nickel. Now, since 100 cents is equal to a dollar, that'd be 5 over 100. So that's a fraction. 5 over 100, 5 hundredths. Now this one. It's a dime. A dime is 10 cents. Oh yeah, everything's over 100 for this. A dime is 10 cents, so it'd be 10 over 100, which also equals to 1 over 10. This also equals to 1 over 20. This is why 20 nickels is equal to a dollar and 10 dimes is also equal to a dollar. This is just a flat out dollar. The Canadians call them loonies. A dollar is 100 cents, so 100 over 100 is equal to 1. Write a fraction for the part of the dollar the coin represents. You don't really need a fraction because this is an entire thing. Now, Sadie went to the pet store to buy fish food. She spent 4 dimes and 10 pennies. What fraction of a dollar did Sadie spend? Now we know that 4 dimes is 40 cents because 1 dime is, well, 10 cents. And our multiplication table says that 4 times 10 is equal to 40. So in dimes, she spent 40 over 100, or 40 hundredths. Plus 10 pennies. Each penny is 1 over 100, or 1 cent. And 1 times 10 equals to 10. So that's 10 cents. 10 over 100, 10 hundredths. Equals to 50 over 100. Equals to 5/10. Equals to 1/2. Sadie spent 50 over 100, or 1/2 of a dollar. Done. Now we move on to section number 5, the last section of the chapter. Hooray! Another problem-solving investigation. Choose a strategy. Antonio picked 24 apples to make applesauce. It will take 12 apples for each batch of sauce. How many batches of sauce can Antonio make? So we want to know how many batches of sauce can be made. We have 24 apples, and we need 12 apples per batch. This slash is also the per sign, like for each sign. Now plan. Choose a strategy. We could just use plain old mass division. We could act it out, but unless you want to find a recipe that calls for 12 apples, go out and buy 24 apples. It might be a little complicated, difficult, time-consuming. And it's not as if your teacher will let you carry a pot into the classroom to make applesauce in the middle of the test. No matter how much you want to bribe the teacher with, well, applesauce. Now we carry out our plan. So 24 divided by 12 is equal to what? Now why 24 divided by 12? So we want to find out the number of batches that, well, Antonio makes. Antonio has 24 apples and each batch takes 12 apples. So the number of batches will be how many groups of 12 is in 24, which is division. So 24 divided by 12 equals to 2. Antonio can make 2 batches. He can make 2 batches. Is the solution reasonable? Yes. Reread the problem to make sure that you got all your facts straight. Antonio picked 24 apples to make applesauce. It will take 12 apples for each batch of sauce. How many batches of sauce can Antonio make? Well, we got that right. How can we check our answer? Well, 2 times 12 equals to 24. Done. Now we can use any strategy we want to solve these problems. Carolina has 25 peanuts and she wants to share them. If she and each of her friends get the same amount of peanuts, how many will each one get? The problem with this question is that they didn't give you enough information. It's a division question, but essentially she could have 4 friends, in which case there would be 5 people to share it with, and be 25 divided by 5, and each friend would get 5 peanuts, or she could have 24 friends and each friend gets 1 peanut. Or she could have no friends and just take all the 25 peanuts. Essentially, this question doesn't have enough information, so you should clarify it with your teacher, or just write not enough information. Because if you were in a higher grade level, then you would say that, let's say n equals to number, yes guys, the hashtag sign is also the number sign, of friends. So it'd be 25 over or divided by n plus 1, which is Carolina, equals to the number of peanuts everybody would get. But, well, we don't have enough information for this grade level, in which case you should probably just tell your teacher. Becky went to the park with 6 friends. 2 of them left early, and 1 got hurt. How many are left to play with Becky? Don't act this out. Do me a favor, please don't. Don't go to the park with 6 of your friends, 2 of them leave early, and 1 of them get hurt on purpose. Don't. That's not a good idea. And if you were to draw it out, then you'd be drawing out 6 circles, and then Becky, and then you would say, these are the friends, 2 of them left early, 1 of them got hurt, there's 3 friends left. Or you could just do, well, subtraction. 6 minus 2 minus 1 equals to 3. Either way, you get the answer that 3 are left to play with Becky. And since we did it 2 different ways, we technically already checked our answer. We didn't get any of the facts wrong. So that question is correct, or at least should be. And yeah, that's it. That's the end of chapter 13.